Welcome to my presentation on ControlFloor. I will be giving a background on how ControlFloor came about and letting you know some of the interesting technical details in its creation. The first thing I would like to do is actually show you a little demo of what ControlFloor actually does. It is an iOS device farm which allows you to remotely view and control iOS devices through a website. So here I have several devices. You can see them in the upper right hand corner here, the actual video feed of these devices in real life. And I can select these devices in the system and see some technical details about them. And I can go to the remote control feed for them, and then I can control them live on my computer as if I was actually interacting with the real device. So I can swipe back and forth. I can click things. I can swipe up and down in the wrong direction. I can go and I can type things. I have a bunch of old notes here. Let's make a new notepad. And the system is extremely responsive, as you can see, working very quickly. And I can go and show you that I can select the secondary device that I have here connected and do the same sorts of activities, as well as the third device. So that's the basics of what this iOS farm is trying to do right now at this time. And I'm going to go ahead and continue on and tell you some more details about how it was actually created, which is quite a long path. So my background, to introduce you a little bit, I did at some point in the past, I guess it's been like 20 years now, I was working for Apple actually as Mac tech support, taking phone calls and working with Mac computers. I don't have any extensive background in iOS development using Objective-C, Swift, Xcode, or any of that stuff. When I began this project about 2 years ago, the majority of my experience has been like Windows development, Linux development, not anything specific for Apple. I pretty much, except for actually working there previously, I've avoided Apple products for the most part, which is rather interesting because I'm now working primarily on Apple systems. So you can see, as I say here, I've used C, C++, Perl, Java, a number of other different languages. This recent project, the device farm itself, is written in Golang primarily, and secondarily in Objective-C. So when I began, I was asked to extend an existing device farm project called OpenSTF in order to, provide iOS support as well. And in the process, I had to learn some amount of Node.js as well, because OpenSTF is written in Node.js. Over time, so initially, the way the device farm was created was as an extension to OpenSTF. At this point, it has been completely rewritten from the ground up and is using Golang and is not using STF whatsoever. So the question is, when you're making a device farm, let me remove these devices from here, they're getting in the way. When you're making a device farm, what do you want users to be able to do? Generally, you want them to be able to, see the device on their screen. You want them to be able to interact with it. And you want them to be able to do such things as install test versions of applications. You want them to be able to see the health of the device, such as memory usage, CPU usage. And you also want to be able to run automated tests that you develop to ensure that your product, the applications that you're creating for your device are working correctly. And the way Apple provides it to do that is mainly through a thing called XCUI test, which is their inbuilt solution. And other people are also using Appium. So Appium actually uses XCUI test under the hood by way of a thing called WebDriver agent, which was initially created by Facebook. So as I mentioned, originally when this was created, it was written as an extension to OpenSTF. STF stands for Smartphone Test Farm, and has many components and is quite difficult to set up. In rewriting this and making a new system, one of the things I've tried to do is make it much more simpler to understand, both in how it works, how to set it up, how to run it, how to debug it, so on and so forth. So what is shown here is just all the different components of SDF, and one of their diagrams showing how the information routes back and forth between it. So it uses a 0MQ, which is a quite good message routing system, but the way they do things is somewhat overcomplicated compared to what you actually need. So after working with SDF for some time, well, actually, so in discussing initially how the SDF extension worked, the way it worked is that there's a thing called a device unit that runs for each device that's connected to a machine. And that device unit is what provides the video stream from the devices. It's what actually routes clicks and swipes from your browser into the device itself. It's what communicates with SDF itself and accepts requests to install apps. It provides back basic information from the device of like what type it is, various information about it back to SDF. So in making a device unit work to replicate the Android functionality, like how this was originally created, the first challenging step is how do you even know that the device is connected to a macOS computer? So, if you're familiar somewhat with Macintosh computers, you'll know that there's a thing called a launch agent. A launch agent is essentially a service that runs perpetually on the Macintosh computer. And you would think maybe there's a launch agent that can trigger to run on a USB device connection. And that sort of can be done, but it doesn't work very well. And what I mean by this is that it will continue to try to run it over and over again as long as that device is connected. So it won't only run when you connect the device. And I don't also think, if I recall, you can't trigger it when you disconnect the device. So another way you can think about is there's a thing called a libiMobile device, which has existed for some time, and it's basically a reverse engineered implementation of the Apple protocols to communicate to iOS devices. And it has a command called iDeviceID, which can actually list all the devices that are connected to a machine. And so one idea you could have is just simply over and over run that command and see like what devices appear, and if a new device appears, then go and do something with it. A third approach, and I initially did this and it worked, but it was kind of confusing and it was quite a mess, is to actually write a system device driver. So actually to write something that pretends to be a device driver that activates a device and makes it do something with your computer. And instead of actually providing any implementation, you can simply only tie into the pieces of it that say, oh hey, a device has become present, notify something, and then go and then don't do anything else. So that was one of the initial approaches, but I quickly abandoned that because the best way to actually do this is to use the API that Apple themselves provides. Well, they provide it. It's a private API. It's called the Mobile Device Framework. So the Mobile Device Framework is a private Apple framework that is used by Xcode itself, and as well as iTunes, any of the things that interact with mobile devices on your Mac. And it has its own methodology for how it can detect that a device was connected. And that is actually what I'm using now for the latest version of ControlFloor. So I actually wrote something similar to the libiMobile device called iOS. Actually, no, my version is called iOS IF. The version I mentioned here, iOS Deploy, is actually one of the things I looked at initially in order to learn about how to interact with the mobile device framework because it's not documented by Apple. So now initially I was using it some like in between period. I was using iOS Deploy to detect those devices, and now I've moved on to my own implementation of this. So the next thing you can think about after you detect the device is connected is how do you actually stream video off of an iOS device? And initially, when this whole project began as an SDF extension, I looked into, and we worked with actually a third-party company to develop an app on the phone that uses ReplayKit. And the way they did it is they actually used an open source thing called HiShinKit, and they modified it somewhat to do RTMP video streaming off of the device. This worked horribly. It was very imperformant. It would crash after about 10 to 20 seconds. You couldn't keep it running any more than 2 minutes, no matter what we did. In the end, the implementation was abandoned entirely, and I moved on. The next thing I considered was, just getting repeated screenshots through something like LibIMobile device. This works, but they're in PNG format. They're gigantic. You can only get several of them per second due to the bandwidth limitations and the slow speed at which it fetches these screenshots. The next thing that was done was tying into AV Foundation. So there's basically a way you can use standard AV Foundation video streaming provided by Apple and call a special trigger to enable those mobile devices to appear, and then you can fetch a video stream that way. This works. I was doing this initially with the version that was working with SDF, but it requires transcoding the video on the Macintosh computer, so you can only connect so many devices to the same machine before you basically use all CPU and all available hardware encoding. So you can only do one hardware encoding at a time. So if you do more than that, you end up using CPU and you very quickly exhaust CPU. So it works. It is an interesting solution, but it's not scalable. And so also in the way I used SDF, it's of interest that FFmpeg actually also provides connections to AV Foundation, and you can also use that in that same way. It's essentially the same as using AV Foundation directly, but you can get some of the benefits of, familiarity with how FFmpeg works. And actually, I'm going to go back a step because the end solution here, which looks like it's off screen here, I'm going to have to fix this presentation, is that I'm now using, once again, the original solution of using an upload broadcast extension. But I'm using Replay Kit 2, and I actually rewritten this from the ground up in order to do hardware encoding of the video into JPEG frames on the iOS devices themselves to then be passed on to ControlFloor. So all these other different solutions that I said are no longer being used because they were simply not viable. So another question would be, are there other solutions? Can you use, for example, HDMI dongles to get video? And yes, it's possible you could use HDMI dongles and then you could use HDMI capture cards in order to capture streams. But then you would have to have the cost of having all these different components. You would have to have them daisy chained to each and every iOS device you're using. You could potentially then, if you don't want to encode on the device, you don't want to encode on your Mac, you could use arrays of other small ARM devices to do the transcoding. You could use something like the Jetson Nano pictured here in order to encode a number of streams very quickly. All these solutions work, but they're complex to develop. They're rather costly compared to things that simply use the existing Apple-provided functionality of Replay Kit 2. So in the end, once again, these are the different essentially overall solutions. Is you can use AV Foundation. It works. You can use Turbo JPEG to encode rather quickly, but once again has problems and you end up consuming CPU. You can use AV Foundation, which is essentially the same thing if you view video through QuickTime on a Mac. It'll show you live feed from your phone, and that's what it's using in that sense. And what's linked here is actually a friend of mine, Daniel Paulus, reverse engineered that AV Foundation methodology, and that's what I was using at some point before now. And so now, and what I've linked here, the normal iOS app, is the current solution, which is simply using Replay Kit 2, encoding JPEG frames on the phone and then passing them directly to the system. And that's quite performant and works very fast compared to all the other methods. So the next question is, how do you actually simulate clicks and swipes on the phone? So the initial thing I tried, and it worked somewhat, was simply to use WebDriver Agent. WebDriver provides the ability to tap on something on screen, but the way it's set up in most cases is that tap function is expecting you to pass an ID of the specific element on screen to tap on. It doesn't let you tap by a specific coordinate on the screen. So, it worked, but it's very slow. There's a 2-second delay for any operation because it has to look at the structure of the screen, find what IDs of the elements exist on screen, and then make another call to use that ID to tap on the element, which then eventually translates that back into coordinates, it's just really inefficient. And it also goes even slower than 2 seconds depending upon how many elements are physically on screen because it's actually dumping the entire structure of the page in XML format in order to do this. It's a bad solution. So one of the things I also looked into was using VNC. It was is there a VNC client that can be installed on iOS devices? No, there isn't. There is. If you jailbreak the phone, You break Apple policy, you go and you basically root the phone, you install City App Store. There's a thing called VNC, which is a jailbroken VNC that actually works, and this works great. If you go through all that hassle, you can get your device to work as a VNC device and get video and interact with it quite well. But a lot of companies are not going to be able to do this because, one, you really don't want to be breaking Apple policy, especially if you're developing Apple apps, because they could just throw you off the App Store because they're obviously not going to like this. It's not a good solution. So the end solution here is actually to use a different call from WebDriver called touch perform, which performs basically these things called synthetic actions on the device. So synthetic actions / events is a way to simulate events such as mouse interactions, like clicking on different things, swiping through a different set of positions, that is supported by XUI test. And then WebDriver Agent is able to tie into that and pass a series of actions into that. And this is good because it actually provides the ability to pass the exact coordinates that you could click on rather than having to click on a specific ID. So this is much, much, much faster. Now, the way WebDriver Agent implements this by default is not performant, in that there's still a, 3/4 of a second to 1.5 second delay, because it's still doing some fetching to determine what application is active. Now, so I've actually altered WebDriver Agent somewhat to avoid doing any of that extra behavior to make it as quick as you saw in the demo at the beginning of this. So the next thing up would be, how do you install apps on the device? So this has been figured out quite some time ago. A LibIble mobile device provides iDevice Installer, which simulates basically the same actions. Well, they're not actually the same, but it simulates actions that actually work to install an app to the device in a way that's, like I said, similar to what Xcode does, but it doesn't provide very good feedback, and it tends to break rather easily. Another solution would be a reverse engineered implementation that's also doing similar to what Xcode does, called iOS Deploy. And this works quite well and is one good solution. There are more modern solutions, such as Go-iOS. Once again, Daniel Paul's created Go-iOS. It's a Golang implementation that interacts with, that does essentially what the same thing as the mobile device framework. It's basically a reverse engineered version of their framework so that it can run on Linux. There's other versions of things that can do this. I won't get into it. So, as I discussed, initially this was created as a STF extension, as a project called STF iOS support. So the way it was created was by analyzing the way the device provider and device unit worked for Android devices and then making an iOS equivalent. Now, what's interesting about this is at some point through my development of this methodology, I actually discovered that people have already done this. There's one of the users on GitHub, Mr. X. It's a person somewhere in China, a company that's working with this. They actually created their own equivalent of this for STF that works with iOS devices. And I don't know how hard they tried to actually make a PR against it, but what I did learn is that by just reading through the PRs and basically the comments and interactions with OpenSTF refused to accept these PRs. And what I learned over time actually is the reason for this is because OpenSTF was created by a company called Headspin, who I believe there are people who have talked at this conference in the past, and I believe they may actually be conducting sessions this year as well. So I don't want to trash Headspin too much, but what I can tell you is they have essentially abandoned STF as a project. And the reason they did that is because they created STF, which I'm very thankful for. STF works quite good. Many people use it. But they created it, and then eventually they created their own iOS support internally, but they did not make the iOS support open. And the reason they didn't do that is because that's how they make money. They make money by selling their solution that additionally has iOS support. So when people came along, I'm one of these people, as well as the Mr. X people in China or another group, when they created iOS support for STF, Headspin refused to accept this as a PR, which is rather disingenuous. It's not really working with the community well. And as a result of this, OpenSTF was actually forked to a thing called Device Farmer. So the entire community moved away from the version that Headspin is in control of, which is, it's unfortunate because it would have been better for us all to cooperate and work together, but it just didn't happen. Another issue with OpenSTF, and one of the reasons I moved away from it myself and completely rewrote ControlFloor from the ground up, is OpenSTF runs Node 8. Node 8 is rather old. We're up to, I believe, Node 13 now. The last I tried to do this, I actually spent a lot of time upgrading the entire SDF project to run on Node 12. I created a long PR to do this. The maintainers of OpenSDF, even Device Farmer, they were not able to merge this successfully because reasons I won't get into. It is possible to do. I did create a PR that exists if people want to do it and want to run it on Node 12, but it's a mess. OpenSDF is, as far as I'm concerned, it's deprecated technology. It should be thrown out, rewritten from the ground up, and that is what I'm doing. So, in the end, after spending over a year working with STF, I eventually said, okay, this has got to go. We need to make something that's better than SDF, that's a lot less complicated, it's easier to maintain, it's able to work well with iOS devices and Android devices. It needs to be simple, standard methods like using REST, not using a 0MQ with protobuf, yada, yada, yada. Like the new system I've created actually just uses straight JSON messages over REST communication and WebSockets. It's much easier to understand what's going on, much easier to diagnose, debug, so on and so forth. So what I show here is actually the architecture for the ControlFloor system that I've created. Essentially, I'll break this down a little bit for you. You have the user browser, which is what you saw at the beginning of this presentation, of just showing the video, letting you click and swipe and do keyboard events. That communicates with a ControlFloor server, which has a very simple database. It has a REST user API as well as a provider API. And then that communicates out with providers. A single provider runs on a macOS machine and in the near future also on Linux machines. And it recognizes devices, iOS devices that are connected to it. And then it communicates out to ControlFloor that those devices exist and it's ready to do things with those. And it provides the information for the video stream to ControlFloor, so that when you activate it within the browser, it can then connect the browser to the server. The server in turn connects to the macOS machine, and then that in turn gets the video from the actual iOS devices, as well as relaying commands all back and forth. So, in the end, what's interesting is that open source has been really great for this project, because in the process of extending the SDF to support iOS, what I found is that there's a lot of people who want to be able to do this sort of behavior. There is no real iOS solution for a device farm that is open source. Many people are trying to do it and failing. And so just by me putting it out there, a lot of people have come to me and say, hey, we want to use this. And it's awesome because I want to work with these people. I want to be able to move the community forward to be able to have a great solution for iOS devices. And I also intend to, once again, add Android device support to ControlFloor so that there can be one single open source solution for all mobile device testing. And of course, this is the Appium conference, and props to Appium for creating something great that layers on top of WebDriver Agent. It also layers on top of the Android tools and provides you a cohesive way to do testing on top of both these things. What I've created is not meant to in any way compete with Appium. It's meant to be used with the Appium, and that's what most people are doing. So, thank you for your time and for hearing me out on all these things. I welcome any ideas and suggestions for the project. Feel free to submit tickets. Feel free to ask me questions. Send me emails. Basically, my perspective is by working with the community, I get free testing, free ideas. Please, if you want to contribute, work on the project, go for it, do it. I doubt many people will do that because it's work. It takes a lot of work to do that. It's what I'm doing full time right now. And I hope that more people will begin using it. Thank you. So I guess one other thing here is what have I learned over the process of doing this is that it's much easier to do something in a minimal way that's straightforward. If there is a documented way to do something that's available, such as Replay Kit from Apple to serve video, use it. Figure out how it works and use that thing. Hacky solutions are interesting and fun to develop, but they don't typically work well. So, uh, unfortunately, Apple doesn't provide documentation on all the different things, so you do end up having to use a number of private APIs in order to do certain things without using Xcode because they don't provide any way to do it from a command line themselves. So some amount of reverse engineering has been done to allow things to be done. Mainly the purpose is so that it can be ported to Linux away from having to use macOS machines. So, you need to do some amount of this, but it's best to avoid it when possible. I would love if Apple actually worked with us and actually, let's communicate with their engineers and understand what's going on behind the scenes and actually create like an official way to do this sort of automation. Like, heck, I would love if Apple would actually say, hey, we are willing to support an iOS open source device farm as the de facto way to do this, and we will work with them to improve the developer experience. I don't think that they will, but I'm certainly welcome to it. And also, one of the things that I've learned over this is it's been a long road. I've been working on this for over 2 years now, and there's a lot of things that I've tried that work terrible, don't work, that were spent months and months and months developing, trying to understand, and eventually I just threw them out and don't use them anymore. But, that's part of the learning process is you have to try many, many different things until you learn and figure out which ways are the ways that work the best and which ways are the most successful, and then you can refine from there. So, if you find something that's very difficult, don't give up. Keep trying, keep looking at solutions. Eventually, you will figure it out. It's just going to require the time and investment of learning about it. Thank you. And here are some links to one, the slides used in this presentation, as well as the two main repos of the project.